Welcome to our presentation. We are Team 302 and will be presenting our affordable housing design. There are three issues that prompted this project. A great population in Vancouver is currently experiencing houselessness. The supply of social housing exists. However, a house that is economically viable, low cost, safe, and permanent is limited. Therefore, our design goal is to create an affordable, prefabricated, 250 square feet modular residential unit, with a price range from $250,000 to $300,000 Canadian dollars. All of our design decisions must also abide by the BC Housing Design Guidelines and construction standards. Our targeted group is single adults, which takes up 98% of the total houseless population in Vancouver. To develop our final design, as seen on the right, the team considered many of the different aspects that are incorporated into one complete unit. These are listed on the left and will be discussed further. First, we have our unit floor plan shown on the left. It is approximately 21 feet long and 14 feet wide, and has all the necessary furniture and equipment included. On the right, the structural frame for one unit is presented. Advanced framing techniques were used to greatly reduce material usage and costs by using only one timber size and uniform column spacing.
Next, we developed our walls, envelope, and electrical plan. As seen on the left, the team identified three walls that would need to be considered in our design. An interesting aspect is that the team used insulation made of recycled denim for a more sustainable design. We also aim to have a high R value, which will in turn require less energy for heating due to greater thermal isolation. On the right, our electrical floor plan is presented. We analyze the power, current, and voltage to properly size each circuit and ensure electrical codes are being followed. The breaker panel and lighting schedule were also constructed and detailed in our report. Furthermore, we designed the HVAC for our unit. For the unit's HVAC, we have selected a heat pump system to heat and cool throughout the year. The calculated heating and cooling loads for one unit are 3,562.5 watts and 1,988.72 watts respectively. Our estimated loads were verified using eQuest, the monthly energy consumption, and the system schematic, all shown on the left. To comply with building codes and provide a safe and comfortable living space, we also added a range hood fan over the stovetop and a ventilation fan in the bathroom. We also considered the unit's plumbing system. The floor plan of our unit led to an efficient plumbing route. Since all the water appliances are on the left side of the unit, as seen on the left image, we were able to minimize the required piping materials. The two supply mains and waistline run parallel to each other and branch to each appliance as necessary. Lastly, a cost analysis was conducted since affordability is a large theme in our project. Modular designs are inherently more affordable due to the reduced labor hours and economies of scale due to mass manufacturing. We were also able to promote affordability through our material selections and simplified unit subsystems. Overall, we can conclude that our design addresses all items in our problem statement. It addresses houselessness in Vancouver as our solution fills the gap in economically viable, low-cost housing. This is because our modular unit is more cost-effective than existing housing solutions. Also, the lack of safe and permanent housing is addressed through our design's focus on making the space as safe and comfortable as possible, with the intention of providing permanent housing to a resident at a very low cost. Finally, the team wanted to analyze our environmental impact. We conducted a lead analysis and concluded that our design comes 6 points shy of the required 40-point threshold to be LEED certified. Given that sustainability wasn't our core priority, coming this close to a potentially certified design is something that this team is incredibly proud of. Furthermore, an SLCA was conducted to evaluate the unit's effect on the environment during its complete life cycle. Overall, the design obtained low scores, which indicate a lesser environmental impact. Thank you so much for listening.